Here's a video discussing the TI-84 calculator project. So I'm going to create this code from scratch. So if I go to Program, go to New, and call it whatever you like. I'll call it 2 points. So TWOPTS. And then we'll ask the calculator to prompt our variables. So I go alpha A, comma alpha B, comma alpha C, comma alpha D. And again, to get to the prompt, you hit program when you're in the actual program editing window, and then go to the IO submenu and select prompt. And then, of course, we have the distance formula, which we know to do this. The square root of, well, actually, I'm just going to do this instead. Alpha C minus alpha A squared plus alpha D minus alpha B. So I'm subtracting the x's and the y's and storing that as some variable stored as alpha E. Now, you could do the square root of that whole thing, but instead, because we want to express the final answer as a radical instead of a funky decimal, in case if it's not a perfect square. So if I go to display, so go back to the programming menu, then IO submenu, and it'll do alpha quotation, comma, alpha E. So that will display the distance as a radical instead of a decimal. Then if I do my midpoint, so that's alpha C, for alpha A plus alpha C doesn't really matter. So you average x's, store that as say F, and then we do alpha B plus alpha D, divide by 2, store as alpha G, and then we'll display that program IO display alpha F, and let's actually store that as a let's actually have that display as a fraction instead of just a decimal, in case if you do get a decimal. And it'll simplify the fraction for us. And then alpha G store, oops, sorry, math frac. There we go. Now we move on to the part of the code that involves the equation line, which can be a little complicated with all the if statements. So before we actually calculate the slope and the y-intercept, there's a situation where we could get an undefined slope, and that would give us an error. We want to be able to stop such a situation in its tracks before it actually computes the real slope. That will happen when the x-coordinates are the same, because then you're dividing by 0, right? Because then you're doing c minus a, which is, of course, 0 when a and c are the same. So what we'll do is we'll make an if statement, if alpha a, and then to get to equals, hit second math equals alpha c. And whenever you do an if statement, you have to say then. So program then, and that's under the CTL submenu when you hit program. And then hit enter again, and you're going to tell it to display. So go to program, IO, display. And what we want it to display is x equals, because it'll be a vertical line when we have an undefined slope. So we're going to have to do quotation marks, x, second math. Oh, that didn't work. Second math equals, and it will end the quotation, comma, and you can do any x coordinate, either a or c. So now that will definitely display vertical line if that happens. Well, of course, if that does not happen, then we have to tell the if statement, well, else run this. Now I'm actually going to compute the slope. If I compute the slope, it'll be alpha c. Nope, actually, it's a change of y, my bad. Alpha d minus alpha b divided by alpha c minus alpha a. And we'll store that as another letter. We'll store as h. You store it any way you want, maybe m for slope. And then also we need the y-intercept of the alpha h minus alpha b times Oops, I messed that one up. Let's say alpha b minus alpha h times alpha a, and we'll store that as alpha I. The reason why I'm doing that is because y equals mx plus b. So the y-intercept when I isolate will be y minus mx. B is the y-coordinate one of my points, h is my slope, and of course, a is one of my x-coordinates. Could also have done d minus h times c, but you gotta make sure you pick x, y coordinates are together in the same point. Once you do that, then you can actually tell it to display the equation, but we want to add maybe another if statement. What if it's a zero slope, right? So if we have a zero slope, we're going to say program if, and what if b equals d? That means that the numerator of the slope will be 0. So second math equals alpha d. Then we're going to say display program IO. We're going to display y equals. So we hit alpha quotation mark alpha y equals second math equals alpha quotation mark comma and any of the y coordinates. So that could work. Or else, then what we could do is we could try to avoid a slope of, if I have a slope of 1 to not show that. So then I could say another if statement. What if my h value is 1? Alpha h second math equals 1. Then display program. And now we're going to say alpha quotation mark alpha y equals, where's equals? Alpha, comma, and then we just want to have say x plus something. So actually, let me put an x here as well, and a plus as well. So we have y equals x plus something, comma, and then alpha I, my y-intercept. Program else, and then we do another if statement with h equals -1, if we so desire. So program if alpha h equals -1, then program display y equals -x plus something. So we go program IO display alpha quotation alpha y second math equals -x second math. Oops, sorry, what was I doing? Plus comma, oh, you need a quotation mark, comma, alpha I. Or else, then we can do the normal situation. Just to display, else display this. And we're going to display alpha quotation mark alpha y second math equals alpha quotation comma alpha h comma and it'll be alpha quotation x plus alpha quotation comma alpha I. And one thing I should have done is insert pause statements, which I forgot to do. So to insert, after we display that by second, insert equals, go program, go down and hit pause. After I do my midpoint, insert, program, pause, And you could have put in a pause at the end if you want, or end. It doesn't really matter. But I think at this point we're pretty much done. So now let's run it. Program, 2 points. So let's say I have 1, 2, and instead of the same x coordinates, 1, 4, got my distance, got my midpoint, and you got x equals. Or let's say I run the same y coordinates, 2, 6, 5, 6, my distance, my midpoint, and y equals 6. Or let's say I have a slope is 1, comma 5, 4, comma 8, I believe. Distance, midpoint, and now he's at the 1 doesn't show up. Same thing will happen if I have a negative slope. If I do 1, 5, we'll do 4, then I'll do 2. That'll guarantee a -1 slope. See negative x. So instead of saying -1 times 1 times x, it does that. And then if I just do some kind of tip, standard 1, 6, just some random numbers here. Distance, midpoint, and the equation line right there. One last thing we could do is we could have right at the end to display, in case if our y-intercept is a fraction, I can do math, frac, math, frac, and then for my slope, excuse me, I could insert math, frac, and finally for I, math, frac. And there we go. There's the code. Okay, good luck.